In this video, we are going to see some predefined function for sorting. First of all, we need to understand why exactly are we learning these predefined sorting functions. It is almost never a good idea to code your own sorting algorithm in a contest. In a high pressure environment, there might be a chance that you might end up making a mistake or your code might be buggy and you won't be able to find the bug. So they have provided us various sorting algorithms and they are available in most of the programming languages and they work perfectly fine. They are very good in terms of space and time complexity as well. And they have been tested multiple times and they have been used by all the other coders as well. So we are going to learn about few functions from C++ standard library. But it is very similar to other programming languages as well. You will find same thing in Java, Python, Golang. Few changes here and there, but the concept remains the same. So the very first function is sort. See, given the vector where elements are arranged in random order, we can just write sort. This is the function that is available in C++. We provide the beginning pointer and the end pointer of the vector. This is the function that is available in C++. And it will sort in increasing order because that's the default behavior. What if you want to sort in reverse order? Like default order is the increasing order. So you will get 1, 2, 3, 4 and 8. But what if you want to sort in reverse order? So you provide r begin and r end pointers of the vector, right? This will sort vector in reverse order. Now let's look at the sorting of array. So how exactly are we going to sort the array? It's very simple. Let's say this is the array that is provided to you. N is going to be the size of array. So you can sort by providing the start pointer and the end pointer. Same thing we did with vector and similar thing we are doing with the array. What about sorting with string? Okay, so let's say this is the input string that you have, key. You sort the string by providing again the start pointer and end pointer, and ultimately you will have e, k and y. String is sorted based on alphabetical order. So if you observe carefully, all the orders are already fixed. Here you are sorting the integers, so we know that 1 is going to be less than 2, 2 is going to be less than 3, right? Here you are sorting a key, so you know A is going to be less than B, B is going to be less than C because it works on alphabetical sort, right? What if you want to design your own custom sort? Well, first we will look at the comparison operator. Sort function requires the comparison operator to decide the order between two elements. Once the order between two elements is decided by the sort function, it will use that information to place all the elements on its correct position. So in C++ we have built-in comparison operator for most of the data types like int, char, string, right? So numbers are sorted according to their value and string are sorted based on the alphabetical order. Pairs are sorted based on the first element and then they are sorted based on the last or the second element. Same thing goes for the tuple. They are sorted based on the very first element, then the next element and then the third element. Okay, so let's look at the sorting of the pair. So you have 1, 4, 2, 3, 1, 1. So as I mentioned earlier, pairs are sorted based on the first element, right? And if the first element is exactly the same, then they are sorted based on the second element. So if you look at this 1, 1 will be the smallest, then this 1, 4 and 2, 3 is going to be the largest. So the very first element of these two are exactly same. That's why our sort algorithm arrange this based on the second element of the pair. Same thing goes for the tuple. Imagine you have a tuple 2, 3, 4 and 1, 2, 3. So first it will check for the very first element, then it will check for the second elements, then it will check for the third element. Now here 1 is less than 2. So you will have 1, 2, 3 and 2, 3, 4. So user defined struct doesn't have a comparison operator. So we need to define our own comparison operator so that sort operation will use that comparison operator to place the element. Now the input of this comparison operator is going to be the another element with which we are doing the comparison. If the value is returned true, the order is correct. If value is returned false, the order is wrong. So let's say you have a struct called as point. X and Y are its parameter. So we are going to define a comparison operator where it takes another point and it checks based on the x value first. We check the value of x of the current point is less than the value of x for the other point. If that's the case, we return true. If that's not the case, then we go for the check for the y, and if value of y for the current point is less than the value of y for the other point, then we are going to return true. If we return the true, that means order is correct and I want the other element after my current element. Let's say we have 3 points A, B and C. The value of x and y are mentioned here, and once we sort, what is going to be the order of this vector vec? First of all, it will check the value of x, right? The value of x for C and A are exactly the same. Then it will go and check for the value of y. Value of y for C is less than the value of y for A. So you will have C, after that you will have A, and then you will have B. A question might arise, why only do we need to compare two elements? We could be sorting thousands of elements here, right? So why are we only thinking about the comparison between two elements? Well, this is the reason. Let's say A is less than B, B is less than C, then you know that A is going to be less than C. Now with this rule, an algorithm, a sort function can partition, merge, swap, or it can also build the heap. Remember, in quicksort, what we used to do? We used to select our pivot element and then we used to compare that pivot element with all the other elements to divide the array into two different sections. All the elements less than to the left of our current element and all the other element will go to the right. So we are going to compare this pivot element with all the elements that are present in the array. Right? So it's ultimately a comparison between two elements. In merge sort as well, that's what we do. We divide the array into two different sections, and at the time of merge, we compare ith element with the jth element. We will have two different pointers, right? And we are comparing two elements only at a time. In heap sort also, we use heapify operation heavily. In heapify operation, we compare our current element with the left child and the right child. That's why the comparison between two elements can be extended to comparison between multiple elements, and by using that comparison, our sort operation will decide where to put all the elements, right? All the sorting algorithms that we saw are based on the comparison between two elements only. So once we define the comparison between our current element and the other element, then we can perform the sort operation. All of this can be done using a binary comparison between only two elements. So our sort operation never cares about the final position of A or rank of A, right? That's why we need a sorting algorithm. If we already know the final rank of A or final position of A, then why do we need to sort it? Our sort operation doesn't ask us the position of A in the final result. Rather, it just asks us the order that we want after the sort operation. By using that order or a comparison operation, performs the sorting on an input array. So comparison between two elements can decide the order, and that is enough for us to sort. There are two different ways to define our own comparison function. Earlier, we saw defining an operator. This can be easily extended to class as well. We are not going to discuss that here because that is not heavily used. So there are two ways to define a custom function to perform the sort operation. Look at this. Here is a function that we have. It will return a boolean value. So first, what it does, that it checks the size of A and B. A and B are the strings, and it checks the size of A and B. Size of A is less than B, then it will return true. That means order is correct. If not, then it will return false, then order is not correct. If size is exactly the same, then it goes for the alphabetical order. So this is how a custom sort looks like. Sort of vector v, where we provide the starting pointer and ending pointer. Also we provide the name of the function. That sort function we'll use to decide the order of the elements in this vector v. There is another method. You can just write something inline. So look at this. You have sort here, you have sort here. You are providing starting point. Here also you are providing starting point. Here you have the ending point. Here also you are providing the ending point. Now here you are providing a function that is defined in this way. But look at this. Here you are directly defining the function. And sort operation will use this function to determine the order. So this is the syntax. You take two input A and B. Exactly like this. And then you write all the logic that you want to write. And the sort function will end up using this particular logic to decide the order. This is the lambda. And this is the function. The very important thing that we need to discuss is a bad comparator. Imagine A being a point. We earlier discussed the struct point, right? Imagine A being a point and B being a point. So what we are saying, the value of x and y after adding up with mod 2 should be less than the value of x and y for the B mod 2. That means the LHS should be 0 and RHS should be 1. Mod 2 can take 0 and 1 only, right? And we have a strictly less than sign here. So it should be 0 and it should be 1. That means the sum of these two values should be even and sum of these two values should be odd. That's what we have written in. All even points come first and then odd points. Now the issue here is that, let's say in an input array you have 2, 2, 4, 4, 6, 6. All of them are even. There will not be any order between them. So order may change unexpectedly or it might change based on the compiler as well. Second problem is that if you insert these 2, 2 into our set, also you try to insert 4, 4 into our set, one of them will be dropped. Why? Because according to this comparison operator, your 2, 2 and 4, 4 are exactly the same. Because 2 plus 2 mod 2 is going to be 0. Also 4 plus 4 mod 2 is also going to be 0. So 0 is equal to 0. So your set of point will think that these 2, 2 and 4, 4 are exactly the same values and it will drop one of them. Set uses this kind of operation to check A is less than B, B is less than A. In this case, this is also false and this is also false. The negation of false and negation of false will make them true and true. So this will be true. Once this is true, set thinks that whatever the value that we are trying to insert now is already existing in the set and it will drop it. So one of them will be dropped. And look at the condition. If A is not less than B and B is not less than A, then definitely A is equal to B. That's why this set can only hold one of the three. All the others will be dropped. I hope this is clear. See, definitely you are going to use sorting with predefined function in a contest. But you should know all the important sorting algorithms. So please watch the entire playlist. We have covered bubble sort, selection sort, insertion sort, merge sort, quick sort, heap sort. We have covered many sorting algorithms. Also we have covered heap data structure as well.